Let's continue with this concept of first principle, finding the derivative of this function mainly by using the first principle. Alright, so okay, the very simple way is you have to understand the formula, where's the formula come from, then later you see what the formula needs. So the formula needs fx plus h, so I'm going to finding the fx plus h for this function, which is replace the x with x plus h. So now I can starting using the formula of first principle. This is the first principle. So as your limits as h approaching 0 for this function, so will be fx plus h, right? Fx plus h minus fx. Refer to this formula here. Okay, so it will be square root of x plus h plus 1 minus with square root of x plus 1. Everything you divided by h. So now I already showed that I using the first principle. But okay, before you evaluate, you have to check. You have to use the concept of limits here. So what happened when you directly substitute the h0 into this function here? So you have 0, right? h0. So you have 0 here. You have square root of x plus 0 plus 1 minus with square root of x plus 1. This is in your mind. So x plus 1 and x plus is exactly the same. If you minus, you're getting 0. This is a case of undefined, indeterminate form. You cannot determine what is the value, undefined, because 0 over 0, right? So for this case, that you have cert, you have function, you have cert on the numerator. So then you're using the concept of multiplication with the conjugate of the cert here. So have the square root of x plus h plus 1 plus with square root of x, right? This is the conjugate pairs for this. So of course you have to multiply up and down by this conjugate. Alright, if you still remember, as I said that if you multiply the conjugate, only the conjugate pairs you expand. Only these two you expand, right? These two don't expand because they are not conjugate pairs. So it won't help in the situation, but it will get worse if you expand this. Alright, so now you have x plus h plus 1 minus plus with square root of x. I just put it side by side, putting a bracket. Okay, put this side by side. I never expand inside the h into the function there. So I have expand the numerator, which square root of x plus h and square root of a multiplied with square root of a, the concept of cert, you are getting a. So you're getting x plus h plus 1, right? Then for this, you will have plus with square root of x plus h plus 1 multiplied with square root of x, right? So minus negative of, here will be x plus 1. I forgot the x plus 1 here. So you will have x plus 1. So now, then now you can see that the negative of x plus 1, square root of x plus 1 multiplied with square root of x plus h plus 1, right? Then followed by negative of square root of x plus 1. Now you can see, this one will be x plus 1. So because the square root of x plus 1, square root of x plus 1, two identical, you're getting x plus 1. So look at these two. Look at these two. They are exactly the same, alright? They represent the same thing here. So as you minus, you cancel out these two, right? So finally, I have limits as h approaching 0. So then on top here, you have x plus h plus 1. You have x plus h plus 1 minus with bracket minus with x plus 1 divided by h. So square root of x plus h plus 1 plus with square root of x, right? So then you try to simplify the numerator. X minus x, you have 0, right? X minus x, you have 0. 1 minus 1, you also have 0. So you have h, you have h on top here, you have h here, x minus 1, 1 minus 1. So you have h, here also you have h. So square root of x plus h plus 1. So this is the factor for the denominator, factor for the numerator. So these two can be cancelled out. So which you are getting limits of h approaching 0 of 1 over with square root of x plus h plus 1 plus with 1. Sorry, square root of x plus 1 here. So here got square root of x plus 1, forgetting. Okay, so now you have plus with square root of x plus 1. So now you can directly substitute into the function, the h0. So you have square root of 0, h0, so x plus 1, plus with square root of x plus 1, and 1 over with this one, 1 plus 1. This 2 is same thing, a, so 2a. So with 2 square root of x plus 1. So it means that therefore, by using first principle, the derivative of this function, square root of x plus 1, you are getting 1 over 2 square root of x plus 1. That's the way you're applying first principle of getting the derivative of this square root function here.